This video is on lessons 3 and 4 from Unit 9, and it's kind of more of the same of what we did in lessons 1 and 2. So if you follow along, I'm going to start on the left side of the bottom of your foldable notes sheet. And the first part asks you to solve the following. So solve means find an answer for x. And this right here, the next part of the sentence, express your answers in simplest a plus bi form. That is a huge indicator to you that you're going to end up using the quadratic formula and you're going to get a negative underneath the radical and have to put it into a complex number and use the imaginary number system. So let's just go ahead and start solving. So as soon as I see an x squared or any variable squared, I think to myself, get it equal to 0, which it already is, and then either factor and then t-chart to solve for x or use the quadratic formula. Well, if you tried to do 1am, there's no pair of numbers that would multiply to 29 and add to negative 4. So therefore I know I'm going to have to use the quadratic formula. So a in this case is 1, b is negative 4, and c is 29. So if I start plugging these numbers into the quadratic formula, it's going to be negative b, so that's positive 4, plus or minus. The square root of negative 4 squared is 16, minus 4 times 1 times 29, all over 2 times a, which is 2 times 1 is 2. If you clean up underneath the radical, it turns out to be the square root of negative 100, and right there is your negative under your radical, which I kind of knew that was going to happen because of the directions. So if I rewrite this as 4 plus or minus the square root of 100 and then I all over 2, now I can work with the square root of 100 since it no longer has a radical or a negative underneath it. So the square root of 100 is 10, so you get 4 plus or minus 10i. Remember, the i is attached to the square root of 100, which turned into 10. And now I can divide everything on top by 2. So 4 divided by 2 is 2, plus or minus 10i divided by 2 is 5i, and there's your answer. So your two answers are 2 plus 5i and 2 minus 5i. Example 2, again, I see the x squared, so I'm thinking to myself, I have to get it equal to 0 and then either factor or do the quadratic formula. So it's not equal to 0, so I have to subtract the 7x over and add the 10 over to get x squared minus 12x plus 40 equals 0. You could sit here and try to come up with two numbers that multiply to 40 and add to negative 12, and it won't happen. So you're going to have to use the quadratic formula. The quadratic formula says negative b, so that's negative 12, so that's positive 12, plus or minus the square root of 12 squared is 144, minus 4 times 1 times 40, all over 2 times 1, which is 2. Underneath the radical, so I'm going to go down here, you're going to get the square root of negative 16. All over 2. Well, as soon as I see the negative under the radical, I'm going to rewrite it as a positive with an I outside to denote that that was originally a negative under the radical. The square root of 16 now is 4, so that's 12 plus or minus 4i all over 2. Divide everything on the top by 2, so my final answer is 6 plus or minus 2i. Now, this will not always happen where the radical is a perfect square. If it's not a perfect square, you do have to simplify it as we have done in the last unit by breaking it down into its primes and circling pairs. The last lesson of this unit is talking about what we call the discriminant. The discriminant is the part in the quadratic formula that is under the radical. So it is only, it doesn't include the radical, it's just the part that's under it. So it's just the b squared minus 4ac. It is important that you realize that if we know what type of number is under the radical, we now know what type and how many roots there will actually be to our quadratic. So there are three different cases really. Well, there's four, but there's three different cases in the number of roots. So if you think about what a parabola looks like, it could either cross the x-axis twice, like so. It could cross once, which means the vertex is going to be on the x-axis like this one. Or it could cross no times, which would be imaginary. Now the reason why there's four is because actually if it crosses twice, there are two different cases. It could cross at nice numbers or not nice numbers, which we call rational versus irrational. So that's why there's four cases, because there's two for if it crosses twice. It either crosses at nice rational numbers or not nice irrational numbers. So here's an example of those following four different scenarios. First one, let's take this equation. 5x squared plus 6x plus 1. If I evaluate just what's under the radical of the quadratic formula, so it's b squared minus 4ac. So b squared, that would be 6 squared minus 4 times 5 times 1. If you do that all out, you end up getting the number 16. Well, if you think about where that is, that's under the radical, the 16 is a perfect square, which means you're going to be able to take the square root of it and get a nice number. It's going to be 4. So when you find your roots, you're going to cross at nice numbers because the square root of 16 is just 4, which means you can then do like, it would be negative 6 plus 4 and negative 6 minus 4 all over 10 because 2 times a. So if you actually found the roots, you would find that they cross at negative 1 and negative 0.2. Yes, that's not the nicest number, but it's also not irrational. It is rational. So if you want to make a note to yourself, if you get a perfect square, you're going to get 2 roots that are rational. So you're going to get 2 rational roots. Rational numbers, remember, are numbers that can be written as a fraction, and if they have decimals, they go on forever repeating, or they stop. So they're the nice decimals, as we call them. Okay, the other way you could have 2 roots that are still real is if you have irrational numbers when you square root whatever's under the square root. So your discriminant will be irrational. So here's an example of one. X squared plus 3x plus 1. If you do just what's under the radical, the b squared minus 4ac, that's going to be 3 squared minus 4 times 1 times 1. Well, that's 9 minus 4, you're going to get 5. You'll notice if you try to square root 5, it's not a pretty number. Okay, it's 2 point something. It's not a perfect square, 5. So therefore, you're still going to get 2 roots, but you're going to get like negative 3 plus radical 5 and negative 3 minus radical 5 all over 2 times 1. So your roots in this case are negative 3 plus or minus the square root of 5 all over 2. So yes, we have 2 roots because we have the plus and the minus version, but they are irrational. So you're going to have 2 irrational roots if the discriminant is not a perfect square. So we got 5. So if it were like 10, 10's not a perfect square. If you got 20, that's not a perfect square. If you got any number that's not a perfect square in the discriminant spot, you're going to have 2 roots, but they're going to be irrational. They're going to cross at really ugly numbers. The next case is if you have 2 roots, but they are imaginary, which means they're not in the real number system. They're in the imaginary number system, which actually those ones are the easiest to spot. So that would be something like 5x squared, if we took this equation, plus 2x plus 1. If you start doing just the discriminant, which is underneath the radical, so you're going to do b squared minus 4 times A times C, you're going to get, that's 4 minus 20, that's negative 16. As soon as you get a negative underneath the radical, you should be thinking, well, duh, it's going to be imaginary because there's a negative under the square root. So you're still going to get 2 roots. Your roots in this case would be at negative 0.2 plus or minus 0.4i. So you're going to get 2 imaginary roots. So they will be, if you graphed this parabola, it will not cross the x-axis in the real world or real number system. All right, the last case, this one's actually an interesting one. That's this picture that we drew over here. This is when you only have 1 root. And if you think about how could you ever get 1 root? Well, if underneath the radical is a 0, then you would be adding and subtracting 0 from whatever negative b is. And if you add 0 to a number or subtract 0 from a number, you're going to get the same number. So therefore, you're going to kind of get 2 roots, but it's going to be the same number, which means it's actually only 1 root. So here's an example of when that would happen. If you had the equation negative 4x squared plus 12x minus 9. So if you just do the discriminant, which is the part underneath the radical in the quadratic formula, you're going to get b squared, so 12 squared, minus 4 times negative 4 times negative 9. It turns out to be 0. You get 144 minus 144. So what that means, if you finished the quadratic formula to find the 2 roots, you would get negative 12 plus or minus 0 all over negative 8. Well, negative 12 plus 0 is negative 12, and negative 12 minus 0 is negative 12. And if you divide both of those by negative 8, you're going to get the same answer. You're going to get 1.5 twice, which we only ever write it once if it's the same exact number. So therefore, this is 1 rational root. So the 2 that you are kind of hoping for that are the easiest to work with is you're hoping for a perfect square or 0, because those are the ones that give you nice roots. If you get a not perfect square or a negative, that's when you're going to have some kind of ugly looking answers. So let's fill in this little, these are like your notes that you need to kind of memorize these sentences. If the discriminant is a perfect square, then there are going to be 2 rational roots. That was our first case. If the discriminant is not a perfect square, you're still going to have 2 roots, but they're going to be irrational. They're going to be the ugly ones if it's not a perfect square. Irrational roots. If the discriminant is 0, that's when you're going to have 1 rational root. And then lastly, if the discriminant is negative, then there are 2 imaginary roots. Now, if you forget these little rules, you can always just find the roots and then figure out if you got 2 roots. Did you get 2 nice roots? That would be rational. Did you get 2 ugly roots? That would be irrational. And then if you got 2 roots that have an I in there, that's imaginary. And then the last one is if you only get 1 root, that meant that the discriminant was 0 because you added and subtracted 0, which is the same, keeps the number the same. And that is it for Unit 9. So next class we are actually going to do the classwork and review so that you can have your test the class after that. So make sure you are studying and doing all of your classwork.